All right, so today we're going to take something in standard form and we're going to put it into vertex form, because when it's in vertex form we can then not only find the vertex, but we can see how our graph moves. Does it go up, down, left, right? Is it a vertical stretch, shrink, whatever? And so that makes it a little bit easier to graph. And so how we do that is by completing the square. Now we did completing the square before, and the process is going to be very, very similar. There's going to just be one difference that you'll have to get used to. So and this is specifically to get it in vertex form, where the other part of completing the square was to solve, to see what x actually equaled. Well, here we're going to do it so that the equation is written in such a way that's more useful for us. So if you remember, first step in completing the square was move our c term to the other side and leave a space. So we're going to do that again. So 3x squared minus 12x, leave that space, equals this -7. So I moved my c term to the other side. What is different is that originally we would then divide every single term by a. Well, instead of dividing by a, we're going to factor out a. So I'm going to factor a out from these two terms that are on the left side of the equal sign. When I factor that 3 out, I'm left with an x squared minus this 4x. And now we have that space, and this is still equal to this -7. So divided each term by 3, and this is what I have left over. Now the process is very similar in the fact that you're going to take half of your b term, and that goes inside the parentheses, so half of b is the -2. And remember, this number is my reminder to square it. So square -2. So -2 squared is a +4. And remember, whatever I do to one side, I have to do to the other side. However, there's another difference here. See how I'm adding 4? Well, I'm not just adding the 4 in here, I'm actually adding the multiple of 3 times 4, because if I were to distribute that 3 back through, it would be 3 times 4. So instead of adding 4, I'm going to actually have to add 3 times 4. Now, we know that 3 times 4 is 12, and so we're going to reduce this, so I really have a -7 plus this 12, and that is a +5. And so this is almost in vertex form. Remember, vertex form is our ax minus h squared plus or minus our k. Well, here's our k. We want that to be equal to 0. So I just need to move this k back over to the other side. So it's really 3 times x minus 2, quantity squared, minus 5 equals 0. So when I move that +5 over, how I move that is by subtracting 5 to both sides. And so this is vertex form. So from here we can see, hey, we have a vertical stretch by a factor of 3. We're moving to the right a distance of 2, so horizontal movement of 2. Remember, it's opposite of our h, so opposite of that -2 would be a +2, and that means we go to the right 2. And then this -5, because it's on the outside of our function, means we go down 5. Well, we can't find all of this from our original function. Now, there are some things from our original that we can find that we can't see easily here. So for example, we have a y-intercept of +7. Well, I can't easily see that in this form. So both forms are beneficial in some ways, and we're going to see that when we get to graphing soon. Let's do that one more time. Number 2, what happens if a is negative? You're going to have to factor that negative out. So remember the first step, move c to the other side of the equal sign and leave that space. So I have a -4x squared minus 12x. I move c, and this is equal to a -1. So I subtract c to the other side. I need to, instead of dividing every term by a, I need to factor out a. So I'm going to divide each term technically by that -4 when I factor it out. Be careful with your signs. I'm left with x squared. A negative divided by negative is positive. 12 divided by 4 is 3, so this is x squared plus this 3x. Here's my space, and then this is still equal to this -1. So remember, I'm only factoring a out from the two terms left over on the left side of the equal sign. Now, we take half of our b term and square it. Well, that's exciting. So we have this -4. And inside parentheses, I have x plus half of 3 is 3 over 2. And that is my square, reminding me to square that term. and then equal to this negative 1. So remember that square is my reminder to square that. So 3 over 2 squared, well 3 squared is 9, and 2 squared is 4. So you square the top, square the bottom. Whatever I do to one side, adding this 9 over 4, I have to do to the other side. But I'm not just adding the 9 over 4, I'm adding this negative 4 being multiplied when you distribute to this 9 over 4. So it's really adding this negative 4 times 9 over 4. Now what's nice here is that this is technically 4 over 1, right? And so your 4 in the numerator is going to simplify or reduce with your 4 in the denominator. So a negative 4 times a 9 over 4 really is going to leave us with this negative 1 minus 9. So a negative times positive is negative. But again, just use your calculator if you want negative 1 minus 4 parentheses 9 over 4. Math, enter. If you get a fraction, so we get negative 1 minus 9 is equal to a negative 10 when I reduce that right-hand side. Now, that fraction was not fun, but half of any number really is just dividing by 2. So we can write it as 3 over 2. When you square a fraction, you square the top, 3 squared is 9, and square the bottom, 2 squared is 4. And whatever I do to one side, I have to do the other, but instead of adding this 9 over 4, I'm really adding a negative 4 times that 9 over 4. Well, this negative 4 times this 9 over 4, if you put that in your calculator, you'd get a negative 9. Negative divided by, or times positive, would be negative. This negative 1 just drops down, so negative 1 minus that 9 is where we get that negative 10. Now you can put that whole right side in your calculator on your own. The last step is that we want it to look like vertex form. So now I need to move that negative 10 over, and I do that by adding it. So I'm going to add 10 to both sides. I'm going to be left with x plus 3 over 2, quantity squared, plus 10, and that is what equals 0. So this is now vertex form. So we see, hey, we're going to have a reflection over the x-axis, so it's going to open down. It's going to be an N shape. We have a vertical stretch by a factor of 4. We're actually going to go left 1.5, 1.5, 3 over 2, and we're going to go up 10. And so we can see things from here that we can't see in standard form.